Hello everybody, and welcome to this first episode of Algorithms of IOI. I know you've all had a wonderful time in Szeged, watching it from home, participating, being a team leader there. There are so many reasons that you were there or you wish you could have been there, but the problems were quite hard. So I came back here half a year after IOI to Budapest. And today I'm going to look at two of the problems, one from day one and one from day two, to look at the algorithms behind it, talk about it, and discuss them. So at home, you know what's happening and what you could have done. So stay with me and we will just look at the problems from day one. Let's look at one of the tasks of day one from IOI 2023. The task is called longest trip. It's a fun task, but before I explain it to you, I want to make sure that you've actually read it as well. So if you haven't read it yet, go to the link, download the task. The link will also be in the descriptions below. Download the task, read it, and fiddle a little bit with it yourself. And then come back here. Welcome back. So you've downloaded the tasks, you've read it, task longest trip of day one of IOI 23, and hopefully you've made some notes about it, which is what I've done in my little pink notebook as well. Just to fiddle with the task and to make it my own. So what I've learned is this is a task about an excursion during IOI to the Oputhazar National Memorial Park. This is an open air park near Szeged with monuments all around the park. And you want to visit as many monuments as is possible. The monuments are connected by roads, but we've lost the map. So the goal is to visit as many monuments as possible, staying on the roads, but you have to figure out what is connected with what other place. So in order to do that, we have a dispatcher, someone that knows about the road system, and we can ask the dispatcher, if I have these monuments and these monuments, is there at least one path between somewhere in this group and somewhere in this group that connects them? So that's the information we can get. So we can ask questions. And obviously we can ask questions about every individual monument, but that's going to take way too much time. Now at IOI, we try to help people. We try to help the students. So we make the task a little more simple than it is, just for the first subtask, as we call it. And here we say for every 3 points, so for every 3 monuments that are there, we know that there are 3 roads connecting them. And if I look at that on my big screen, I have my screen behind me here. So here are the monuments. If I look at them, I can see here I've marked 3 monuments, and for subtask 1, I know that for every 3 monuments, there are always 3 roads there. So you know that those 3 are completely connected. I can also look at 3 other monuments. And I see the same thing. Those 3 monuments are connected as well. Well, if I look at those 3, what happens if I put in another monument, a 4th monument? Well, a funny thing happens. You can see that everything is connected to everything else, because those 3 monuments have 3 roads, those 3 have 3 roads, those 3 have 3 roads. So every group of 3 monuments has 3 roads connecting them. It gets even better, and you can see a pattern emerging here. You can see that this is a graph that's fully connected. Every monument has a road to every other monument. So this is a little fun thing that you find out when you fiddle with the task. So at first you have no grasp of what's happening, but you fiddle with it and you see, oh, this 3 roads for every 3 monuments basically means the graph is fully connected. Is that still a hard problem? No, it's not. Because if everything is connected to everything else, you can just start wherever you want to. I've picked one, I've started there, and I can take any next monument to go to because I know everything is connected. So for instance, I could decide that this is my next one, and I know that this one will be connected to every other monument as well. You see that? But it's also connected to where I'm starting. So I will just move this monument there and pick the next one. And as you can tell, the same argument goes, this one is connected to everything else as well. So I can just keep picking random monuments and keep adding them to my list. And all I need to output is those monuments in order. So that would be a solution for subtask 1. Now, this only scores 5 points out of 100. So if you want to make a quick 5 points, you could just write a program that does nothing, does not think about anything, and just starts outputting a random order of all the monuments. So that's trivial to do. Another thing that you could do for this subtask, if your program is very trivial and just checks, is there a monument that's connected to it, then I will output that next. Then this problem would also just score a full score because there's no problem there. So this is subtask 1. Not worth very many points, but it's there to get you into the problem and to get you to fiddle with it and to get you to understand what's happening. So now that we've learned about subtask 1, we're going to look at subtask number 2. For subtask number 2, you can see that for every 3 points, there will be at least 2 roads. So if I look at these 3 monuments, what options are there? Well, they could still all 3 be connected, because at least 2 does include 3 roads. We could have only those 2 connected. Only those 2 connected. And finally, obviously, we could also have only those 2 connected. Well, does this make the problem a lot harder? Well, not really, because once again, I can start with a random point that I've selected there. And now I go look at the next point. For some reason, I put them in a circle, I just look at the next point. And if they are connected, then it's not a problem. I will just move that to the next one to go see on my fun little journey to all the monuments. But it gets interesting. What if it's not connected? Well, now something funny happens. Because we know that every 3 points there are at least 2 roads, that means that there is at most 1 road missing. Basically what's happening here is, because I know that there's no road here, I know that this one must be connected to everything else, because the 3 points that are these 3 and that one, I know that those are always connected. So one way to look at this is to just grab any other point and add that to your list of points. See, I've shown it here. This one is connected to everything else. This one is connected to everything else, just like I said. So it doesn't matter which other point I choose, as long as I don't choose this point. Now, isn't that a cool, clever little trick? And this just comes with, from fiddling with the problem. And now I've decided to choose that one. Boom, that one's been added. And I know that that one must be connected to this one as well, because that's what we've seen. So I can still add that point to it. Boom. And we'll just keep going this way. Basically what we're doing, if the next point we choose is connected, we'll connect it. If it's not connected, we can choose any random other point, connect that, and then still connect this point, because we know that one is connected to the one that's not there. See what I'm doing here? I choose one, and I'll just keep going all the way till the very end. Now it gets a little bit interesting, because this is one of the nicer edge cases. If the last point that we're trying to add is not connected here, you may think we have a problem. But in fact, we don't. Because we know that this point is connected to every other point there, so we can just connect this point to the other end of our path. And then we have the solution. So for subset number 2, we just do the same thing. We go through all the points in order. There's nothing special about it, except for the last one that we may need to connect to the beginning. So I really enjoy this subtask because it shows me more depth and it gives me more of a chance to just fiddle with this problem. We'll be back with subtask number 3. So we're going to look at the third subtask. The third subtask is still doable if you diddle a little bit with it, and it's worth a lot more points than the first one. So this is worth trying out. So for this subtask, there are 2 things that are important. One thing is that for every 3 monuments, we know that there is at least 1 road. So for every 3 monuments, there is at least 1 road. And the second important thing is that we're not trying to find the longest path. You score points already if you come up with a solution that is at least as long as half the length of the longest path. And so that makes this subtask strange, but also very doable. And it also nicely leads towards the final subtask. But let's look at this subtask. So we're saying at least 1 connection between every 3 points. So if you look at the screen, I have already selected 3 of the monuments. Now, if there is no path between those 2, and no path between those 2, then we know that there must be a path between those 2. So the information that we're getting out of this subtask is basically information based on what is not there. If you have a road, you don't know anything about the other things because there's at least 1 road. But if there are no roads for 2 of the monuments, you know that the next connection must have a road. Well, let's go back to our circle of monuments, empty it out. We'll choose a nice first monument to start with. And then what we'll do is we will just look at all the other monuments and see if we can find a monument that we're connected with. And if we can find one, then we just add it to our path. And if we don't, we just look at the next monument and we just keep searching until we find a monument that is connected to this. And you may say, yes, Kim, but what if we can't find any connection to any of the other monuments? Well, now we have an interesting thing. Remember that I just explained that if there are no roads between those monuments, you know that those must be connected. So from this monument, because we have nothing that goes to anything else, we know for 100% certain that all those roads must be connected. Nothing here, so there must be a connection here. Nothing here, there must be a connection here. Nothing here, must be there. Same way, it must be there. So basically, what we're doing here is at the end of the day, we have a solution where we have 2 paths that are not connected. And we don't know what the longest path is, but we know that we have all the points in here. So even if the longest path is every point, then our solution will have at least half of all the points in there. So that's really clever if you think about it. So we just have 2 ways of going to visit the monuments, and we choose the longest one, and that is what we'll output. And because the longest one will be always, half of all the points or more, we know that no matter what the longest path is, we will also always output at least half or more of the longest output. Isn't that cool? Now for the last one, I'm going to need some help. So I'll be right back because I have to find one of the professors here at LT University to help me out with the last one. I'll be right back. Poof! We're back with my good friend Zsolt. You're a great professor here at LT University, and you're going to help us out with this last bit, right?
Yes, exactly. So thank you for finding me, Kim. I'm not sure if you remember, but the last time we made a video together, I finished by saying I will be happy to host IOI 2023, because then I won't have to explain tasks on video. So here we are.
I'm so sorry. That was in Indonesia, and you thought I would never find you again. Well, here we are, and thank you all for watching us. So I've left us off at the last bit of subtask 3. So we found everything that's connected, we found the path, and we know all the stuff that's not connected to this. Help me out. Can I do better than half of the maximum length?
Okay, so yes, in the last part you showed us how to find a path that is at least half of the length of the longest path. But now let's just try to improve upon your solution and try to find the longest path in the same setup. So you can remember you were building your path one by one, and maybe you got stuck at this point. So at this point, you already deduced that these must be connected. Actually, not by just a simple path, but any two of these will be connected. Right? Because neither of them are connected, is connected to the other one.
Because these two are also not connected, so this is a fully connected set.
Exactly, yes. So we will somehow try, if we can, to integrate this part of the road network into our original path.
Okay.
But the problem is you cannot just simply look for a connection between these two components, because you may not be able to integrate it in the end. So before we do that, we do one extra step, one observation. We will check if here in your path, the first and the last monument are connected or not.
Okay.
And there are two cases. If they are not connected, then remember that these two were also not connected. So these two will be connected. Oh my God. These two will be connected, and then
it's easy, because we just
you just extend the original path with this.
Okay, so that's easy. That's an easy thing. Okay, now let's go for the harder stuff.
Okay, so the other case is if these are connected. So in this case, we have two components guaranteed, and both of them form not just a path, but a cycle. This is a cycle, and you can make any cycle of this as you want to. So at that point, we will go to my original question and check if these two components are connected.
Okay, but we can ask a question. We can just ask a question to the auditor, to the software, because this is the thing. So far, I've only been asking single questions, and now all of a sudden, we need to be able to ask the full question. Is this set of points, is there any connection between this set of points and between this set of points?
Exactly. It's important to remember that you can ask or you can query about sets of monuments, not just single monuments. So we can just ask if those are connected, and if not, then we know that there is no way to connect any point from here to any point there. So it means we are back to the previous subtask.
Well, the previous solution, but we know we actually have the maximum length.
Yes, exactly.
Okay, so then we know that the previous solution already gives them the longest path.
Yes, that was
okay, now let's make it harder again. So what if there is a connection?
Yes, so if we have a connection, then we have to find one exact connection. So we will do this by binary searching.
Okay.
So we fix one set of monuments, one path, and we try to always split the other set of monuments into half.
Okay.
And after a few queries, you will be able to find one single monument that is connected to some monument from here.
Right.
And after that, you turn it all around and fix this monument and try to binary search over the other path.
Okay.
Until the point you have a connection between two concrete monuments.
Oh, I see something now. Because obviously I can see this path that is longer,
Yes.
but they were cycles, right?
Yes.
So I could just go around. So I could now have this whole path, and I have all the points in there.
Yes, you are correct. That will give us the longest path.
Okay.
Because over this cycle, we have these two cycles, we have this connection, we can just visit them in an order just as you mentioned, and we have a longest path, and in this case it turns out that the longest path actually contains all of the points.
So just to be, I'm just interested in this. Do we need to do the binary search, or is it also fast enough if we just try every possibility?
So you can try out every possibility. The thing is, even with if you try out all the possibilities, you will solve the last subtask. But we haven't mentioned yet, but in the last subtask, your score will depend on the number of queries you use.
Right, so the binary search is just there to lower the number of queries that is necessary.
Exactly, though there is still one catch, because using your original idea to create the first path is not optimal, not good enough to score the maximum amount of points.
Ooh.
This solution in the worst case would cost you about 1,500 queries, and for the full points you will have to solve the task with at most 400 queries.
And this is an interactive task, right?
Yes.
So this, for the people at home, is very important. Because it's interactive, it means that Zsolt has not come up with the graph beforehand, and I could be lucky or not lucky. He is actually an adversarial player against me. So when I ask stupid questions, you will give me the answers that give me the worst possible situation. So that worst possible runtime is actually what I would hit every time because of the way you give your answers.
Exactly.
You're deciding on the graph based on the questions that I ask. And that's similar to if you're just a little sidestep, similar to if you play a game of think of a number, and I know I've mentioned this problem many times, but if I think of a number between 1 and 2,000 and you have to guess it, if you start by guessing stupid, do a dumb guess.
5.
Is it 5? He asked me, it's higher. And then 10. Higher. And you see where this goes. I will just keep saying higher and higher because I will choose the answer that will give him the largest number of possible answers that are still available. If he is smart and he starts by asking 1,000, I can say higher or lower, but it doesn't matter. Immediately you disqualify 1,000 of the answers. And so in a similar way, you guys do this here. I ask questions, is this connected? And you just think, okay, what answer can I give that's still valid with all the previous answers, but that makes it as hard as possible for Kim to find a solution?
Exactly. So we have to brace ourselves for the worst possible answers given by the grader, and we have to find a way to reduce the number of queries.
I am so glad that I brought you in. And what we'll do is we'll set up the slides for the final solution, and then please help us then. So we'll be back with the slides for the final solution. The final part of the solution for this task, longest trip, and I'm still here with Zsolt. Zsolt, we are going to improve on the question asking. Help me out here. What is your new idea?
Okay, so you can remember that in the end, the previous solution boiled down to having 2 separate paths and trying to connect them somehow. So a way to improve upon the whole solution in terms of the number of queries is to build 2 paths independently right from the get-go. So we will try to build 2 paths, and we will always assume that we have 2 paths in the building. And we will try to add new monuments one by one.
So I'd like to file an official complaint with you, because my original slides for subtask 3 did exactly this. My original idea was I build these 2 paths and I start adding this one. And let me go to your next slide. If I can connect it, I can connect it. But if I can't connect it, I will try the other one. I could connect it there potentially, but then if I can't connect it to either one, I know that those two must be connected. So you're saying that my original idea was actually a valid idea?
Yes, it's a perfectly valid idea, and you can see here that if you are unlucky, in the worst case, you will ask 2 queries to add a single monument to one of the paths.
And you're telling me that we need to do even better than that?
Yes, so if you do it like this, you probably won't score full points, only slightly less. So we will have to find an improvement, and we want to present here an idea that is easy to prove, that it gives us a lower number of queries than how you did. Okay, so let's go on to what do we know? We will add this. Yes, we will follow the steps of your solution. So if we can add this, if there is a connection here, we asked 1 query and we added 1 monument. That is good for us. If it is not connected and we don't know anything else, we have to ask a second question. So at this point, we have 2 questions and 1 monument added. But we can store and remember that there was no connection between those 2.
So now when we look at the next one, we know some more information.
Exactly. So we have 2 cases. If it's connected, then we can add it to the path right away. And remember that in that case, we asked 3 questions. 2 for the previous monument and 1 for this. And actually, if there is no connection here, we are still at 3 questions, and now without an extra question,
we can just add it immediately because we know that that was not connected from the previous adding, and we know this is not connected. Oh, that's pretty clever.
Thank you.
No. So I had not come up with that. So that's pretty clever. So this is just a way to ask fewer questions, because now this gets important.
Yes, because actually that's why I reject your objection to the original slides, because from your original slides, even though they contained a good solution, it was very hard to deduce if that actually improves upon 2n queries or not. But this way we will actually prove it.
But can we do even better than this?
We don't know, but there is still one more case we haven't mentioned, because we mentioned if there is a connection here, it's good. If there is no connection but a connection here, that's also good. But there is one more case. If there are no connections here altogether, we cannot do the previous idea, so we have to come up with something else. So in this case, we asked 2 questions, and we will play big and bring in 2 more monuments and ask 2 more questions.
So we know that those 2 are not connected.
Yes.
And then we ask those 2 questions, and we can get those answers.
3 possible answers. No connection, 2 connections, 1 connection, or 0.
So what can we deduce from this?
Okay, so it turns out that looking at these 3 cases, in each of these cases, we will be able to form 2 paths from all the monuments. And remember that we asked 4 questions, and we are going to add 3 new monuments. That's even better than 3 over 2 in this case.
So here we know we can add this one, and we already have the second path with 3 ones.
Yes.
Here we know we can add this one, and we know something here as well.
Yes.
But is that helpful to us?
In that order, not. We can add this, that's correct, but actually this one and this one must also be connected.
Because of this hidden triangle in there. So we can immediately add this.
Yes, and the other 2 form
and this is a new
path.
chain.
Yes.
And here, what do we do here?
Yes, and here we just look at the individual triangles. So there is a road here, and a road here. So all of these will be on a single road, and this single monument will be the second one.
So by just asking those 2 extra questions, we get so much more information. And we've drawn all the roads here to make it a little bit easier, but that's really clever.
Yes, and this idea is a bit difficult to come by because, you know, when you are thinking about a problem like this, you can easily block yourself, like, oh my God, I did 2 queries or 3 queries and I cannot deduce anything. So I think it's difficult to come up with the idea to add more and more queries to
How many
squeeze
students
out more
came
information.
Up with this?
Sorry?
How many students came up with this?
With this exact idea, not so many, I think, though there are other ideas similar to this, with a similar combinatorial nature that gives you the full score.
Right.
So with this, or with a very similar idea, I actually don't know how many contestants solved the problem. It was in the range of 20-ish or something.
But that's more than zero.
Yes, exactly.
Right? And this is one of the goals at IOI. We're trying to rank the students and find out who is better than who else. And that's why we have all these separate subtasks, so that you can start easy and we make it harder and harder and harder. And here you can see that the final optimizations that Zsolt has explained here are important to us. I see we have more slides left. Why do we have more slides left?
Yes, because we seem to forget something. Because our previous solution to the suboptimal, our suboptimal solution to this subtask required 2 cycles in the end to merge or not merge.
And it was guaranteed to have 2 cycles because of the way we were asking way too many questions.
Yes,
because of that, we already knew that there were 2 cycles. Here we don't know that yet.
Yes, and that's a problem that actually we can overcome with a very limited number of queries. With at most 4 queries, we can solve this problem.
Well, 4 queries to me implies we just look at the endpoints, because there are 4 endpoints, potential roads.
Exactly. It's a natural greedy idea. Try to connect any 2 of the endpoints. Okay. Because if any 2 of the endpoints from one chain and the other chain is connected, we can just merge the 2 chains.
If anything is connected, we can just change it into one. And if they're not connected, so this is, we just merge it into a single one. If nothing is connected, now I see here triangles again. So what are we saying now? Are we guaranteed to have a cycle now?
Yes, so in this case, there are many triangles, but if you look at, for example, this specific triangle, it proves us that this is a cycle. The first and the last must be connected. And also here, by doing the same on the other one, it is also a cycle.
So that's really clever. So we look at these endpoints, and again, this is like an actual big triangle in there. Not connected, not connected. So this one must be connected. We know we have a cycle and we can run our binary search.
Exactly. So at this point, we got back to the last part of the previous solution, which is kind of optimal with the binary searches. So this is enough to score full points.
So cool. This is such a cool task. This is one of those tasks that I think is a real gem, because it looks very hard and then you start peeling at it and it turns out to be easy, but then you're working your way into it and then you think, actually, it is hard.
Yes, exactly. There are so many little details in these tasks, like little ideas. All of these ideas are relatively easy. You can, as you mentioned earlier, you can just sit there, scratch some notes, come up with each of the individual ideas, but you have to merge them together into some complex solution. And also it's important to mention that in this task there can be a few corner cases. Like if one path is a single point, then the ending might be a bit different, and similar other ideas that we won't mention in this video, but they exist.
But it's truly a task of algorithmic nature. Your data structure doesn't have to be overly complex. Everything is reasonably simple because you just ask questions and you get your answers back. You don't need to come up with clever new data structures. This is really an algorithmic task.
Exactly. So the code itself is not super short because of the corner cases, but you can just sit there and type it out using the most simple data structures you don't need.
Just sit there and type it out. Well, I hope you've enjoyed this explanation. I hope you've read the task. I hope you understand the solutions. And now it's up to you to just sit there and type it out. Thank you for watching this explanation of this task from IOI. I hope you understand the problem and the solution. And now it's just a matter of sitting down and typing it out. And thank you, Professor Zsolt, here from ELTE University in Budapest, for coming here and explaining it to us.
Well, thanks for having me on these videos, and thank you for having the chance to explain it to a wider audience. And of course, thank you for accepting our invitation to come here and explain and do this task together.
I love doing these things, and we will be back with more tasks and more solutions. Thank you.